Welcome to Lecture 15, Section 3.6. So we're still focusing on lines, and what we're looking at now is the intercepts of lines. Alright, so definition here. Intercepts. The intercept of a line is the point at which it crosses either the x or the y axis. So if you think about something in general, if you're thinking about the definition of intercepts, what do you think about? Well, intercept is when something crosses, like you intercept a pass in football or something. Okay, so intercept, where it crosses that point. So if we're looking at a graph, we have the y-axis and the x-axis. When we're talking about the line's intercepts, it's possible for a line to have two intercepts, the y one right there and the x one right there. That's one possibility. Okay. And so on. So let's take a look at this in a little more detail. Getting ahead of myself here. Alright, so which intercept are we looking at? Well, if we're looking at finding the x-intercept, if we have a graph and a random line, let's look at a few different types of lines. I'll do them in different colors. So here's one line. Ooh, that's supposed to be a pen, not a highlighter. Okay, so we have one type of line right here, the slanted line. So this one would have an intercept right here at this point. So now a question here. We may not know what value the x is there, but do you know what the y value is? Take a moment and think about that. Along any point that I make here on the x-axis, what is the y value? We always know what the y value is here. And you might be like, huh? The y value is always going to be 0. No matter what point I pick along the x-axis, the y is always 0. Okay? So how do we find the x-intercept on a graph? We just look at where it's crossing the x-axis. Another option we could have for a graph is if you had a line, a vertical line. Does it have an x-intercept? Yeah, it does, right here. It, in fact, has that little one right there. Let's look at one other type of line. We have slanted, vertical, and what's the next one we can have? We can have horizontal. Give me a second, I'm going to do some erasing. We can have a horizontal line. Now, does this line cross the x-axis? No, it doesn't. So this one actually has no x-intercept. Okay. So, those are some of the different options you might have. Alright, so for given an equation, how would we find the x-intercept? What we're going to do, just like we saw before here, is for an x-intercept, we notice that the y value is always going to be 0. Regardless of where the point actually is, the y value will always be 0. So because we know this, a sneaky thing we can do is say, well, if I'm given an equation, let's say, for example, y equals 2x plus 1, to find the x-intercept, I'm just going to set y to 0, because I know when y is 0, that's going to be my x-intercept. So set y equal to 0. We'll go ahead and do that. Plug 0 in for y. So we get 0 to x plus 1. Let me actually go ahead and back that up a little bit. Squish some work in. Ooh. So then we have negative 1 equals 2x. And then finally, we have negative 1 over 2 equals x. Alright, so our x-intercept would be... Now you got to be careful here. This is one way that you need to show your work as well when you're showing work on an exam note. It needs to be a coordinate point. Okay, this is very important. You wouldn't just say y-intercept half. You need to say y-intercept and then answer as a coordinate point. Very important once again. Please answer as a coordinate point. So, when you're given a graph, you're just going to look for the point at where it intersects, and when you're given an equation, you're going to set y equal to 0. So now, let's look at the y-intercept. Well, when given a graph, it's a similar idea. as working with the x-intercept. If you have that horizontal line, you're just looking at where it crosses, this time the y. And that value, wherever it is, we may not know the y value, but we do always know the x value. Regardless of what point we're looking at along the y-axis, the x value is always going to be, that's right, 0. Oops, I did that wrong. The x value is always going to be 0 for a y-intercept. Alright, so let's say we have a vertical line. Do we have any y-intercepts? No, we don't. It never crosses the y-axis. So this is no intercept, no y-intercept. And then the last example, let's go ahead and look at that horizontal line. Does this have any y-intercepts? Yeah, it does, right there. And this point, we know the x value is going to be 0, even if we don't know the y value. Alright, so very similar to the x. Let's go ahead and look at finding the y-intercept when we're given an equation. So once again, let's use our example from before. So this time, we're going to use the same idea we used before. To find the y-intercept, we know the x value will always be 0. So we can use that handy little clue there and set x to 0. Okay? Because wherever the y-intercept is, the x value is always going to be 0. Okay, so to find the the y-intercept, we're going to set x to 0. So y equals 2 times 0 plus 1. That's going to be y equals 0 plus 1. Y equals 1. Alright, so the y-intercept, once again, we're going to answer as a coordinate point. 0, 1. Okay, so right here, setting x to 0 and setting y to 0 for finding intercepts is a very important tool to remember. So put that one in your toolbox. Alright, let's move on to the next example. Or actually, let's move on to the first example, which is find the x and y intercepts for each of the following. Well, for A, we're given an equation, which means we're going to be using these steps here. To find the x, set y to 0. To find the y, set x to 0. So for the x-intercept, what's our plan? We're going to set y to 0. So let's go ahead and do that, plugging in 0 here in our equation. Minus 3x equals 6. 2 times 0 is 0, so we have negative 3x equals 6. We'll go ahead and divide to solve for x. Minus the 3 divided by the 3. X equals negative 2. So remember, we're not just going to answer like this. That is not an intercept, or that's not the correct format for writing out your intercept. We want to answer as an ordered pair. So negative 2. Alright, take a second and try see if you can solve for the y-intercept. Alright, so for the y-intercept, you set x to 0, and then we're going to plug that value in to solve and see what we can get for the y. So that becomes 0, it's gone. So 2y equals 6. Let's go ahead and divide by the 2 to get y by itself. And then we have y equals 3. And there we go, our y-intercept. Once again, answering as a coordinate pair because it is a point. Alright, let's look at the next one for part B. Now this is just a graph, so all I'm going to do is just figure out what these 2 points are. So this one here, is that an x or a y-intercept? Well, it crosses the y-axis, so it's a y-intercept. So it's going to be a y-intercept. And remember, we need to label it as a point. Let's see. So this is going to be 0. And then 1, 2. 0, 2. Now the next one, we have a crossing right here. And that's going to be an x-intercept because it crosses on the x-axis. So the y value is going to be 0. So let's check the x values. We have 1, 2, 3. 3, 0. And let's do last one here with C. So once again, finding x and y intercepts. Go ahead, pause the video, and check back in with me in a second. Alright, so for the x-intercept, we always set y to 0. So I'm going to set that up there. And then let's solve that. So 4x plus 6 times my y value, which I'm going to input as 0. Remember, we're using this equation. Minus 4 equals 0. Well, that's me 4x minus 4 equals 0. Let's move the 4 to the other side. So 4x equals 4. Solving for x, we'll divide both sides by 4. And x equals 4. But hold up, don't circle that. Don't resist that temptation. Our answer, remember, it needs to be that ordered pair because it is an intercept. Ooh, that was a bad box. All right. Still not that great. Anyways. All right, let's go ahead and do the y-intercept. Hopefully you went ahead and tried to solve this one by yourself. Okay, so we're substituting 0 for x and solving for y. So that goes to 0. That's going to be 6y minus 4 equals 0. Solving for y, we'll add 4 to both sides. And we get 6y equals 4. Going ahead and dividing by 6 to get y by itself. We have y equals 4. We might be tempted, 4 over 6. Might be tempted to stop, but remember, we need to simplify if we can. These are both divisible by 2. So y equals 2 over 3. That's not our final answer, remember. We need to write it as a coordinate pair. Hopefully, because I've reminded you so many times, everyone will write out their answers like that perfectly on their exam. Alright, so for graphing lines. Our steps are going to be first, find your slope. And box your answer. Second, you're going to find your x-intercept. And box your answer. Why boxing answers? Just so that your work is neat and clear. Third, find your y-intercept. Okay, as usual, boxing your answer to show your work neatly and clearly to the person who is reading it. And thirdly, you're going to graph. And important, remember arrowheads. Alright, so let's go ahead and work with these steps. Alright, so we're given an equation for a line. And we're told to graph it. List the slope in any intercepts. Okay, so first things first, let's do step 1, find the slope. Alright, well, we're given an equation, so to find the slope with an equation, we want it to be in slope-intercept form. So, slope-intercept form, if you recall, is y equals mx plus b. Very important form to remember for finding slope when given an equation. So remember, we can't just pull the value from the x right there for my slope. I need to get this into slope-intercept form. So we're going to go ahead and solve for y. Let's add or subtract the 2 from both sides. So negative y equals 3 minus 2x. Divide by that negative 1 from the y to everyone. And then we get positive y equals negative 3 plus 2x. Okay, so this actually isn't quite in the correct form yet. We're going to go ahead and swap these two to get it in the slope-intercept form. Alright, so now it's in slope-intercept form, and I can pull my slope off, which is 2. So my slope is 2. Third step. Let's go ahead and find the x-intercept. Okay, so setting it up for my x-intercept. To my equation, 2x minus y equals 3. We're going to go ahead and substitute 0 in for y. And I'm dividing both sides by 2. We get x equals 3 over 2, which is also 1.5. But we can leave it as that for now. And lastly, or at least third step, my y-intercept. Setting up x is 0. Using my equation, we're going to go ahead and plug in 0 for x and solve. That was hideous. Okay, there we go. Remember, as usual, lining up the equal signs nicely is always important. Okay, so 2 times 0 is 0, and then we have minus y equals 3. Dividing by that negative 1, or you could multiply by negative 1. Then y equals negative 3. Remember, we're not just going to box that answer. We need to answer as a point, negative 3. Please box as a point. I don't want to be taking any points off people's work on their exam if they're not in a coordinate set. It's not fun to do that. Okay. The last step is to graph this. Let's do this. So when you're graphing, you're going to plot. There's 2 ways you could do it. You could plot one point, one of your intercepts, and then use your slope to count rise over run. Or you could use your y-intercept and your x-intercept, and then use your slope to find a third point. But please note here, you need to have 3 points. Okay, I will be checking this on your exam notes. You need to plot 3 points. Now, you might be going, why? Well, because 2 points can always create a line. For example, this point and this point, I could always draw a straight line right through those. Well, that's supposed to be straight. But if you're plotting and you accidentally mess up your work calculation somewhere, and you plotted out your points and they look like this, you would know there was something wrong with your work. There's no way that is making a straight line. So 3 points is a way to keep yourself from making an error. So you need to plot 3 points. I will be checking for 3 points. So you might say, how do I get the third point? I know that this is 1 point, and that's another point. How do I find my third point? To find your third point, you're going to use the slope. Okay, let's get rid of all my fairly large circle marks here. Okay, let's go ahead and first plot our intercepts. So, plotting the y, which is, remember, 1.50. Let's see, 1.50 right here. Please always label your points. And then our y-intercept, 0, negative 3. So 0, 1, 2, 3. So down to negative 3. We have 2 points. We need 1 more. How am I going to find it? The slope. So to find the third point, two over and 1 to find my run. So how do I read this off? Well, I know this is my rise value, so I go rise 1 because it's positive 2, and then I go right 1 because it's positive 1. So rise 2, or you could say up 2. Actually, that might be an easier way of saying it. Up 2. Right 1. Okay, so the question then is, which point do I start from? Now remember, we're not starting from the origin. Okay? You're starting from either your y-intercept or your x-intercept. If we started from our y-intercept, we're at this weird halfway point, and it's kind of awkward counting out halfway points. So I'm going to avoid using my x-intercept, and I'll go with my y-intercept. So I'm going to go up to 1, 2 over 1. Boop. And there we go. Is my other point. And what would that one be? That is, looks like positive 1, negative 1. And then we'll go ahead and draw in our line with our arrowheads. Please, please remember the arrowheads. I do not want to be taking points off for no arrowheads. All right, so that's graphing a line. Now let's go ahead and work this out one more time. So pause the video and try to graph the line by yourself. Please make sure there are 3 points, and then check back in with me when you're done. Alright, so we have our graph, or our equation here. So first things first, I'm going to find the slope. Well, that's really easy with this because it's already in Y-intercept form. So I can go ahead and pull my slope off right here. So m equals -2 over 3. So finding my Y-intercept, or actually X intercept, and go ahead and set it up. Something 0. So y equals -2 over 3x plus 1. Plugging in 0 for y, we get 0 equals -2 over 3x plus 1. Let's move that 1 to the other side. -1 equals -2 over 3x. Okay, so now how do we get rid of that fraction? Simple, just use the reciprocal. So now multiply by the reciprocal, -3 over 2. Because when we do that, the 3's will cancel, and the 2's will cancel. But we have to multiply the other side by the same reciprocal. So then, let's see, we have -3 over 2 times -1, and I'll put it over 1, which we can do, remember, x. Well, negative times a negative is a positive. And then, so we have 3 over 2 equals x. Alright, so the next thing is going to be our y-intercept. 0. So solving for our y-intercept, you know, we could spend a lot of time solving, but I'll show you a trick. When it's in the slope-intercept form, the nice thing about the slope-intercept form is it has to do with why it's called that. Well, remember, the slope-intercept form looks like, give me a sec, y equals mx plus b. Now, it gets its name because when you're reading from left to right, remember, which is what we always do, the first thing you'll see is your slope, and then you'll see your intercept. This guy here, the b, is an intercept. And which intercept is it? It's your y-intercept. Okay, so that's how this guy got his name, slope-intercept, because most of the time in math, the names are not that creative. They're often just saying it how it is, which makes it kind of simple sometimes in trying to remember things. Okay, so that's using that. So if I use that idea, that whatever's being added to this equation is my b, then my y-intercept would be 1. But first, let's check this with what we know we can do. So plugging in 0 for x, let's see what we get. Well, that goes to 0, so then y equals, what do you know? Y equals 1. So, yep, that does work because you're always plugging in 0 for x. So this value is always going to disappear, and whatever is left over is your intercept. All right, there we go. So now we have 2 points. Let's go ahead and plot those. Let's see. Zero, 1. Ooh, so small right there. And if you need a reminder on how to plot points, just shoot me an email and I can try send you a video on how to plot points. And then the x-intercept is 1.50. So let's see. 1.50. Ooh, this is small. And remember, always label your points. 1.50. All right, so to find the third point, what are we going to do? Use the slope. That's right, we haven't used it yet. Might as well use it. So our slope is -2 over 3. What does that mean? -2 over 3. Well, this means we're going to go down 2, because it's the negative, and then right 3, because it's a positive. But where are we moving that from? Remember, we have 2 choices, either the y-intercept or the x-intercept. Since the x-intercept has a weird half point, I'm not going to use that. I'll go ahead and use the y again. So let's go ahead and go down to 1, 2, and over 3. 1, 2, 3. And there's my other point, and it does look like it's lining up. So this looks like it's 1, 2, 3, 3, -1. Alright, go ahead and draw in our line because now we have the 3 points and they line up. And lastly, our beautiful arrowheads. And there we go. That is it.